Hey guys, this is Parth from FTC Team 7477, and today we're going to be talking about a very useful tool in FTC programming, which is the IMU, or the gyro. And the gyro is located inside the actual control hub, so for all FTC teams it comes inbuilt and there's no external parts needed. And what the IMU does is return an angle of the robot from negative 180 to 180 degrees. So it's a big part of accurate robot localization, and it allows for you to get an accurate estimate of where your robot is on the field. So to implement your IMU into the code, first the configuration on the phone should be automatic. The IMU should already be configured into the I2C bus 0. So now we can get into how to code it. So you're going to start with defining the IMU object. So we're just going to create a new IMU object. Make sure to import it. And it's just going to be public. We're just going to call it IMU for short. And now, I'm going to be working in the base class that we have created from the previous tutorial. And if you haven't created this base class, please go to the previous tutorial to see how to set up this base class if you do not know how. But once you have that, you want to initialize your IMU through the hardware map like all other objects. And the line is just going to be IMU hardware map.get. It's going to be IMU.class and the device name in your configuration, which is by default IMU. So we're going to call it that, and that instantiates your IMU. But to initialize your IMU angle, you need to specify a couple more parameters, which are basically its orientation on the robot. So the possible orientations, there's a couple possible orientations. So it can be like the logo facing down, up, left, or right, and the USB facing forward, backwards, left, or right. So we can look at that right here. So I can call the IMU.initialize function, and what I want to do from there is create a new IMU.parameters object to pass into that. And we're going to actually call another object called new REV orientation on robot. And what this will do is specify the REV hub's orientation on the robot. So we can just do this, as you can see, by calling the REV orientation on robot. And we're going to start with the logo facing direction. And as you can see, we can choose down, backwards, up, left, forwards, right. We're just going to choose up. And furthermore, we do the same thing for the USB direction. And as you can see, again, there's forward, up, backwards, down, left, right. Again, I'm going to call forward for the USB direction. And that is how you initialize the IMU. And basically what this line of code is saying is like, okay, get the IMU from the configuration, and then initialize the parameters so that the REV orientation, the logo is facing up, and the USB ports are facing forward. So now that I have it all initialized, I actually want to use it to find the angle. And what we're going to do for that is we're actually going to create another function within our base class only that gets the angle for us. So we're going to call this public double get angle. And if you don't understand why we're calling it a double, is because we're returning a double. If we were not returning anything, it would be void like init hardware. But since we are returning something, it has to be a double. And what we're going to be returning is a robot angle. So how we do this is let's create a double angle equals IMU.get robot yaw pitch roll angles. And what this will do is return all the angles that the IMU is detecting. But the thing with the IMU is that it detects angle movement in 3 directions: yaw, pitch, and roll. Pitch and roll are on 3-dimensional axes, so the only thing you really want to worry about is your yaw, because that's your side-to-side heading. Yaw. Heading is another name for yaw, which is what you need of your robot. So then from there we can specify get yaw, and then we have to specify an angle unit. For the sake of this tutorial, I'm just going to say degrees, but you can also choose radians if you would wish. But for now, I'm just going to choose degrees. What this is doing is instantiating my angle double as the yaw angle of the IMU in degrees. Um, the IMU, this new interface, there was an old interface, but this new interface makes it very easy as the angle is already normalized to a negative 180 to 180 range. And what this will do is accommodate many turning functions. So, meaning that we'll talk about this in later tutorials, but it'll be the robot will take the shortest turn to an angle, since the angle is already normalized. And don't worry about that right now. We'll cover it in later videos. But now we actually need to return the angle. So now this will get me the angle of my robot. So now let's go back into the actual teleop that we created last tutorial again, and we have the init hardware. And what that's going to do now is it's going to initialize our IMU as well. So we can add a telemetry, which we know how to do, just to show. And what we're going to do is we're going to pull from our base class and use the getAngle function. So now if you run this program using your getAngle function, just go in here, it's going to return your angle, and if you can move your robot and you'll see the angle updating. Thank you for watching this video, and in later tutorials we're going to be using this angle to actually do things like autonomous movement. Thank you for watching.